The topic of today is simply dig into data with your spreadsheets. I want you to see what is possible with software that we all readily have access to. So the goals are actually pretty simple for today. Mainly, I want you to learn what you can do in a spreadsheet, and I'll illustrate that with some examples. So we'll cover each of these, but just so that they're on your mind, we're going to do a little bit of pivot tables, filtering. We'll compute things with the simple formula. Conditional formatting is a powerful tool to sort of highlight parts of your data. We'll do a couple charts, do some sorting, and then there is something called descriptive statistics, which even if you're not a statistician, some of this will make sense to you. In the end, I'm hoping that the end goal of today is that you'll realize the value of application programming interfaces and real-time software, which was actually a topic in a previous webinar. When you see what you can do in a static sense, analyzing data in a spreadsheet, you now realize the power of automated software that would do that for you. So this is the outline for today. First, we'll just scroll around the menu of spreadsheet just for a little bit to see where is sort, filter, where is data analysis, what is the function wizard, where are the charts. Then I'll show you how to run the add-in to get access to the statistical tools in Microsoft Excel. And then for the bulk of the time, we're just going to demonstrate analysis of some animal data. But first, I want to just remind you that this is not magic. Not magic at all. It's relatively straightforward, and even you can analyze your own data. Before we actually get to the spreadsheet, this is extremely important. I'm hoping that you will learn from the mistakes of, well, you know, maybe me, maybe lots of other people I know. It's very important that you work on a copy. Let me repeat that. You should work on a copy of your data. It's so important that in your setting, wherever you are right now, why don't you just repeat after me and say it out loud? I should work on a copy. The reason is this. In the working on the data, you might mess it up, and you don't want to do that to your original. You want to always maintain a copy of the original, so you should always work on a copy. Let's go do it. Here we are in Excel. You can see I have several different sheets here at the bottom. We're going to dive into those shortly. But first I wanted to just scroll around the menu a little bit. Of course, we're familiar with Office products and many other pieces of software. We call this the ribbon, where there's a ribbon, and here's the home ribbon, the insert ribbon, etc. Last week in the webinar, we kind of primarily focused in the formulas ribbon with names and auditing. Today, we're primarily in the data ribbon, but we'll also be on the insert to get a pivot table. But I just want to point out here on the data ribbon, there's something called sort, which hopefully is self-explanatory. You can sort your data on a certain thing. And now when you sort, you want to choose wisely and make sure you have all the data selected before you sort, so that one data element that's aligned with another stays aligned with that. But you can sort it alphabetically, by number, by date, etc. And then you can more quickly find the data that you're after. Likewise, you could use a filter, and we'll do a little bit of that, where you can turn on a filter and essentially then only see the data that you're particularly interested in at the moment. Now, I happen to have on my data ribbon this thing called data analysis. And I suppose that when you open up Microsoft Excel, it's not there. So let me show you how to get it. That's under File, Options. It has to do with customizing your version of Excel. And it's called an add-in, which means it's something that came with Excel in the first place, but it wasn't sort of on the surface ready for you to use. It's an odd-looking page here, but you just go to Manage the Add-ins. And you'll see that I've already checked the box for Analysis Tool Pack. I've also checked the box for Solver because I find that to be a powerful tool on a different day, maybe. Analysis Tool Pack brings the statistical package into Excel. So that's how you get it. File, Options, Manage Add-ins, Go, choose the Analysis Tool Pack, and then it will show up there. We will use that a little later. Of course, also on the data, Home ribbon, Nope, I'm wrong. It's on the insert ribbon is where charts are. So we could also generate charts and visualize our data. So since I'm trying to drill into you the notion you should always work on a copy, that's what we're going to do. This is some original data that I received from a colleague and friend from Animal Sciences, Dr. Jackie Borman. This is sort of the raw data that she gave me. So let's just scroll around there a little bit. There are several columns here. Probably some of these things are kind of obvious, the date, the cow number, an identifier, the daily yield. This happens to be milk yield in pounds per day. Here's a yield in session 1 and a yield in session 2. That's the morning milking and the afternoon milking, essentially. So hopefully these things, as reported by the milk collection system, the software, hopefully those two always add up to the daily yield. So while I'm in here, let's go over here and I'll hit end down arrow just to get to the very bottom of this. So you can see there are 4,300 some odd rows of data here. What it is, it's 140 different cows and nominally 30 or 31 days worth of data. That's the original. What I did do is trimmed that a little bit because I didn't need all of those columns. So I trimmed it so that there are fewer columns to work with. So let's work with this. And the first thing that I intended to do was to generate a pivot table with the average milk production for each cow and then look at it over time. So we're going to go there and just do it. I'm suspecting that pivot tables, at first glance, are going to look complicated. Don't worry about it. It just takes practice. It took me several times to actually get familiar with it, and it's often a trial and error experience. So while my cursor is in that table of data, I will insert a pivot table. You'll notice that it automatically found all of the data in that worksheet. And it's going to put the pivot table report on a new worksheet. So it's going to be a new ply in this workbook here. It's going to be quite like magic. And so I get a pivot table tool. Now, I'm just going to share this mostly so that you can chuckle. The first time I did this, I accidentally clicked over here and then I lost the menu structure for the pivot table and actually was at a loss. Where in the world did it go and how do I get it back? Well, you click back in the pivot table and it comes back. If only I had known that the first time, I could have saved a lot of stress. Probably took a couple of years off my life. Anyway, let's put cow in row. Let's put daily yield in as the values in the table. These quadrants here will make more sense when you see an example rather than me try to explain them. When I drag daily yield in there, it by default gives me count of daily yield. Well, I don't really want to know how many. I want to know the value. So I have to change the value settings to not be the count or the sum or the max or the min. Those might be of interest with different pieces of data, but I am more interested in the average. So I'm going to change that to average, and now it will show average of daily yield. But I also wanted to look at it by date, so I will put date in the columns. Not sure why it does this sometimes, but here it's sorted by month, but I really wanted just the date itself so I can look at individual days. So I'm going to drag month out of the pivot table, so to speak. So I just click and a drag. And then I get by date. So here is cow number 5237, her milk production each day of the month of data that I have. This is a pivot table. Now, let me just point out some things that are quirky about Excel pivot tables. First of all, this is called grand total. It's a mislabel. It's not grand total. Total implies sum. But since we have the average of daily yield there, what this really is a grand average, not grand total. And if you hover there, you see that what it's saying is it's the average. So this is the average of all those days. So this is sort of the average for that particular cow, that month, etc. Now, the other thing I would scold Excel about here, shame on you, Microsoft Excel, way too many digits. Like, how accurately do you know milk production? maybe to the 10th of a pound, but certainly not any more digits than that. But this is just the default, so you have to take it as it is. I could take the time. Maybe I should click that column and change the number of digits. Well, it won't do it. Well, I'll have to do it sort of by range. I could change the number of digits displayed and fix it, but that's too tedious for me to do throughout this webinar. But just be wary. Don't get too excited about the digits. You have what you started with, and you must deal with that. So there is a pivot table that shows by cow every day, which of course you could wrangle that other data to make it look like this, but this is a quick way to do it. Now, while you're in the pivot table, I want to point out that you can also filter within the pivot table. By default, it uses all the cows. If I only wanted to look at a subset of the data, maybe I just want to look at these 4 cows. And maybe I didn't want the whole month. I only want particular dates. And since this was the month of September, maybe I only want those 3 dates. It'll take the whole of that pivot table and only show the filtering or the subset that I had selected down there. So let's go ahead and select it all again so we can see it all. I just wanted to show you how to filter within the pivot table. All right, we could also, but I won't take the time to do it, put milk yield in here as a filter on the whole table. And maybe only look at the cows that produced more than 90 pounds of milk on average for the day, or per day, and only display that. So that's a quick pivot table. We'll do some more of that in a little bit. All right, let's do this while looking at that pivot table. Oops, wrong sheet. That's sheet 1. Did you know you can double click on the sheet name? And instead of calling it sheet 1, sheet 7, I'll call it pivot of milk production, so it makes more sense to me. Let's go to the right of that pivot table. And of course, that thing that's labeled grand total really is grand average. But something else that is of use, so I'll give you a very brief statistical lesson here, is something that we call the coefficient of variation, abbreviated CV. The equation for coefficient of standard variation is standard deviation divided by the mean, and then that whole thing multiplied by 100. So let's just compute it. Equal standard deviation, which is a function in Excel. But maybe you don't know which of these do I want. There are several of them. So let's escape out of there. And let's go to the function wizard so that I can show you. In the function wizard, you can find all kinds of help on all of Excel's intrinsic or built-in functions. Well, in this case, I really only want the statistical ones. And actually, I'm looking specific for standard deviation. So if I just look for the word standard, then I will get the short list here. And if I scroll down, I can choose and read one at a time. STDEV is a function, estimates a standard deviation based on a sample. Standard deviation based on the population. Standard deviation ignoring logical values, and several. Anyway, the one I want is STDEV. So if I use the function wizard, what it does is it helps me populate the arguments or how you fill out the function. Well, in this case, I want the standard deviation. I am in row 5 at the moment. I'm in cell H5, if you notice over here. And what I want to do is compute the standard deviation from B5 all the way over to the last element of the data, which is AE5. And then, okay, that is my range. So now let's fix the digits because they drive me crazy. Let's say that at the moment I only have standard deviation, and I told you that the coefficient of variation is standard deviation divided by the mean. All right, so I need to edit this actually, and it should be 100 times the standard deviation of that range divided by the average of that same range, being 5 colon AE5. Now, I just typed B5 colon AE5, but I could go click and drag if I would rather do that. So here I have the coefficient of variation is 5.8. So let me copy that, Control C. I'm just going to drag down, drag down, drag down to the bottom of the table. And Control V is paste, or I could go up to Edit and paste. And then I get, so I will show you just one or two. If I put my cursor in a different row and I try to edit that formula, you'll see that it's computing in row 8 now, 100 times the standard deviation divided by the average of that same range. So I've got the CV of each one. Alternatively, I could have computed the standard deviation in the pivot table. Back here, instead of choosing average of daily yield, I could compute standard deviation, which is different than variation. But notice that CV, coefficient of variation, isn't there. So actually what I'm doing here is about as straightforward and compact as we could do. So here's what I wanted to indicate. CV is a measure of the variation, but it's normalized to the values themselves because you're dividing by 100. The advantage of that is you have a normalized value. So as you think about it, would you want lots of variation or not lots of variation? It depends on your data, of course, but probably in the case of milk production, I want a high value that's consistent. Consistent means low CV. So let me show one more thing here quickly. If I highlight all of that data and go to the home ribbon, there's a thing called conditional formatting. And there are lots of different ways to do it. I'm only going to illustrate one, and that is color scales. The first color scale would give green to high values and red to low values. I'm going to choose this one. I think it'll be obvious after I do it. Red for high values, green for low values. I'm going to choose that one. So that now, very visually, I see that I can see which cows have a low CV, which is green, high CV is red. So I might pick this one and say, why is her milk production so variable? Well, let's go across that row and just look. Well, there was milk production, milk production, milk production, and then there is no milk production. So what happened? This cow went dry. That's why there's such a high variation, because within that month she was producing milk and then all of a sudden she was not. So that might sort of, in the sense of consistency of milk production, essentially be an outlier. And actually, if you study these that have a very high CV, either, let's look at this one, either they were dry and then started producing, or they were producing and then went dry. Here is a slightly different story. So if you know much about cows and milk production, can you predict what's happening in this case with number 5610? She probably just calved before the first day in this data set. So she started at low at 30, 53, quickly ramped up to 70s, but was just coming on to her lactation cycle at that time, which is why the variation is relatively high. What I would now like to show is a combination of filtering and a scatter plot. But I don't want to use the pivot table that we're looking at. I want to actually use the data. So let's go to the milk production trimmed version. And on the data ribbon is something called filter. So watch right here below each of these, or in that top row of each data row column. If I turn filter on, a little filtering icon shows up. If I click it again, it goes away. But let's leave it there. And then what I can do is choose and only look at the data of one particular cow. So watch what happens over here on the left, where before it was every row, 1, 2, 3, 4, all the way up to 4,323. When I turn the filter on, it's 1 and 2, skip down to 149. Skip 150 to 295 and show more. So I'm only seeing the data for this one cow. So with that in play, now let me insert a scatter plot. I'm just going to not connect the dots and just get a default little Excel chart here. Let's move it up to the top. It's kind of gibberish. So the first thing I would do is right-click, select the data, and when doing any chart in Excel, unless it looks exactly like you were expecting, I tend to just remove all that it thinks it wants to plot and tell it, no, don't plot that. Plot exactly what I'm telling you to chart. And in this case, I want the X values to be the date. So that's going to be from the very top of this data set all the way to the very bottom. And then I'm going to plot on the y-axis the milk production, which is from all the way at the bottom to the top. Now I will see the milk production of the cow that I've chosen. Let's switch it. Let's not look at 5237. Let's try 5292. And I'm going to see her milk production over time. I'm not really happy with this chart. I didn't label the vertical axis and the horizontal axis. I should take the time to do that, to call this milk production in pounds per day, and to call this the date, and eliminate the thing called series 1, which means nothing. But in the interest of time, I won't do that right now. But let's switch and look at a different cow. 5289 as an example. And another feature of Excel when you have a scatter plot is to go ahead and click on the data in that chart. And if you right-click, I have a motto that when you don't know what to do, you try like right-click, like when in doubt, right-click. Let's add a trend line. Even if you are not a guru in statistics, this can be insightful. First of all, you'll notice that you can choose different sort of functional forms here. In this case, linear is probably as good as anything. You can display the equation. You can display the R squared. R squared is what we call the correlation coefficient squared. It's an indication of how well does that equation explain the phenomena going on here. So I move that equation over just as the text box so that you can see the slope here. X is the date. So an increase in day by 1 is a 1, plus 1, plus 1. And the slope being minus 0.49, essentially, means that this cow is giving 0.49 pounds milk per day less each day. Well, there probably is a reason. This cow is relatively late in lactation, and there is a drop-off in milk production. If that was not the case, then this data now gives me insight. Well, why is she starting to give less milk? I could do that same sort of analysis on the whole herd, or at least all of the cows that were at the same nominal days in milk status. So this is a combination of using filtering and a chart. Add a trend line to the chart to get some insight regarding your data. If you're anything like me, or lots of students that I've had, actually saying the same thing more than once is not a waste of time. So let's do some similar things with the activity data over here. What we have is the date, the cow, the activity in session 1, that is between yesterday's late milking and today's early milking, and the activity between the first milking and the second milking. These numbers have the values of steps per hour. So what I might want to do is to compute the average of the steps per hour. So it's the average of this one and that one. Of course, if you're unfamiliar with the term average, you could use the function wizard to get it. Now, before I go any farther, I want to make you understand that what I just did is not entirely correct. When I averaged 142 and 129 to get 135.5, I made the assumption that there were the equal number of hours in session 1 as there were in session 2. And in fact, they might not have been the same. So everything I do from this point forward is really only approximate and probably in error, because what I should do is what's known as a weighted average. If there were 14 hours averaging 129 and 10 hours averaging 142, I should take that into consideration. But I didn't in what I just did. However, I don't know the number of hours, so I'm just going to run with this, at least for today, and illustrating, what to do with data. Now what I need to do is get to the bottom of the row here and paste that formula in all of them. So now I have sort of the average of those two numbers, remembering that, well, that's not truly the average number of steps that the cow took per hour in the day. But let's start there, and then let's insert a pivot table. First thing I want to do is take the average steps per hour and put it in the values. I don't want it to be the count. I want it to be the average again. I will take the cow and put it in the rows. I'll take the date, put it into columns. Let's get rid of month so that then I have it sort of by day. And then if I scroll all the way over, then you'll remember from just a little bit ago that although this says grand total, what it really means is grand average, because I'm averaging across here. Now, what I do want to indicate that is that in a pivot table, it's relatively dynamic. That is, it's actually computing these things from the original data over there in the other sheet. So what I want to do to show some other calculations is actually copy the whole crazy thing. Like copy the whole data table, highlight the whole thing, scrolling down to make sure I have the whole thing. I'll right click and copy. And then below all of that down here, I'm going to paste. But instead of just Control V or paste, what I want to do is paste the values. And so now what I have up here is sort of a dynamic table looking at the original data. Down here, I have a static version. These are just static numbers that I can now do things with. So one of the first things I want to point out is there are lots of these divide by 0 errors. So let's first get rid of those. So I'm going to highlight that whole table. Use something that we did just last week, actually. Highlighting all that. Let's use Control H, which is the search and replace. Search and replace every hashtag div/0 exclamation with, I'm going to replace it actually with nothing and replace them all. But I'm doing this in, certainly it's a copy of the pivot table. And it made 681 replacements. So why did I do that? That's so that if I ever compute things from all of this, I have those errors gone. The reason I wanted those errors gone is so that I could show you descriptive statistics. That's under data and data analysis, descriptive statistics. I've already been here, so this was a little bit pre-filled out and I want to get rid of it. I first must tell it the range. Well, I don't want to include the labels. I only want the actual data. So it starts in column A, which is the cow number, cow ID, and it will scroll down to the bottom here. I don't want the last row because it's a row of averages. And then I want to go all the way to the right, but I don't want the last column because it was also averages. So that's my data. The data is grouped in rows, not columns, and the label is in the first column. That's the cow number. I'm going to put the results in the descriptive statistics sheet, and the results that I want are the summary statistics. Okay, turn the crank. Magic happens. I get a new sheet. Hopefully it will have a nice name, descriptive stats, and it's a little bit voluminous because it repeats the labels over and over and over. But what I essentially have in groups here for each cow, and I'm just going to do some highlighting so you can sort of, it will a little bit more jump out of the screen on the screen for you. For each cow, here is the average over all of those dates, standard deviation, and if they mean anything to you, the mean, mode, standard variance, standard error, etc., max and min, these sorts of things. Lots of data, lots of labels repeated that I find voluminous, but for each animal then, the descriptive statistics. I'm hoping that now, as you see what it is that I could do with this data either in terms of doing a pivot table or descriptive statistics, certainly back to the milk production, where we drew this line of productivity over time, you realize that this is tedious. For some types of data, what I've shown you as tools and capabilities are going to be useful. But I'm also thinking maybe you now realize the value of an API, an application programmer's interface, so that that data doesn't just land in a spreadsheet for you to later analyze, but actually some computer engineer or software engineer would have written some code to automatically analyze that data and just tell you by text or alert that something is odd as an anomaly detector. But if I just started there and said, wouldn't you like an API and software? It's a little bit more of a tough sell. And I'm hoping that by seeing how data is analyzed and also giving you some tools so that you can analyze your own data, now you realize the power of APIs and automated data flow. So that's a quick walkthrough with what you can do in spreadsheets, analyzing data. Let's do some Q&A, and if as part of that you'd like to see a demonstration of some of that again or see something new, feel free to ask. Let's use chat and let's do some Q&A.